Hi guys, my name is Ivo and I'm from mytestedasp.net. A little bit about myself. I have been working as a CTO in a large software development team. Additionally, I have been a part-time technical trainer for more than 6 years now. I have been teaching modern C# and JavaScript technologies. In my free time, I tend to write quite a lot of code. I create open source projects for the ASP.NET framework, for the old one, Web API 2, and for the new one, Core MVC. This project, for example, is about testing the ASP.NET Core framework. You can easily assert every part of your web application in a fluent and strongly typed manner. Take a look around, you may like the project and decide to use it. What is interesting is that initially I thought these projects will be quite easy to implement and it will take me, for example, 2 or 3 months, but this project alone has been developed for more than 3 years now. And during my development process I learned quite a lot of useful techniques because I had to analyze the official ASP.NET Core and Entity Framework Core code bases, and I kind of learned a lot from the giants in the industry, from the official Microsoft developers. I learned very cool and useful C# features. Recently I decided to start sharing my knowledge in this YouTube channel, and subscribe to it if you want to learn more advanced C# tutorials, because the internet is full with beginner friendly lessons and courses, but if you want to learn something more advanced you will need to search quite a lot. So I decided to fill that gap, and hopefully you will learn something from me. Okay, this video is all about expression trees. In my previous video I made some sort of an introduction to expression trees and explained how we can analyze and create expression trees during our application runtime. Now I promised in my last video that I will show you a real life applications implementation using expression trees and how we can save some magic strings from our controller code in ASP.NET. If you're not familiar with expression trees, I suggest you watch my previous video. I will give a link in the description, and after you watch it you can return to this one to see the real life example. Okay, let's start. I will create a new ASP.NET Core project. We'll call it Web App Expressions, and I will create a new controller. I will inherit the base controller class, and I will write some action which I want to redirect to the index action of the home controller. The default method I have to use works fine, but needs magic strings. Besides the redirect, there is also an accepted at, which again uses magic string, and created at action, which again uses a magic string. Here it is. The link generation functionality of ASP.NET uses magic strings too. URL.action. It expects a magic string for the action and the controller. These approaches are completely fine, but if you have, for example, I had a large application with a lot of custom routes, lots of them. During the development process we decided to change one of the route, and what happened is that a lot of links broke in our application, and it was a complete madness to find them all and fix them, because with magic strings we didn't have compile type checking and we didn't have IntelliSense. So essentially the value we are going to get from expression trees is compile time checking and safety from changes, because if we decide to change something in our app, the C# compiler will throw an error and we will have to fix our redirects or URLs. I believe it's quite useful. Of course, you will add some overhead because we're going to use this action, this method, with a little bit of expression trees on top, but trust me, we have been using expression trees in our controllers in one of our largest applications and we haven't hit any performance related issue with this approach. So you may give it a try and see whether you will like it. I have two libraries for that kind of problem. One of them is this one and the another one is Parser, this one. So these libraries essentially provide that functionality. They give you an option to generate links in a strongly typed manner and provide quite a lot of extension methods. Currently this library works for .NET 1 and .NET 2. I plan to upgrade it when I have the time, because my schedule is quite tight, to .NET Core 3 too. The another one is for the old ASP.NET MVC, which, if you happen to use it, you may find useful this library. Again, it provides strongly typed extension methods for link generation, redirects, even model state dictionary. Okay, that's great. Let's see how we can implement the same functionality here. What I want to do is I want to call return redirect to home controller, calling index action, having the same having strongly typed method call and strongly typed controller, which allows me to have the same functionality without using magic strings at all. Later in this video I will show you how to even provide magic strings, even provide root values and parameters in a strongly typed manner. You may use the name of operator here like this, but still it's a little bit more ugly as a code than the approach with the expression trees. And this one is a little bit shorter. Okay, let's create an infrastructure folder which will contain infrastructure code, for example, extension methods, code base that just help us write better code, and so on. I will create a controller extensions class which needs to be static, and I will create public iAction result redirect to tag controller. I will use a generic parameter for the controller I want to redirect to. Okay, and I'll say this controller, then I will need an expression action of the controller. Again, if you're not familiar with expression trees, I suggest you to watch my previous video where I explain how expression trees work, and then you can come back here later to understand this example. Redirect expression. You may use func here, func object for example. You may use func with task, for example, if you want to use asynchronous code, but action is more than enough for this sample. Of course, this will not be a production ready code. You will need to make sure that everything works correctly in all available cases, but the whole idea is here in this video, so that won't be any problem. Okay, first let's see whether this compiles. I will need to make the method static in order to make it work, and if I reference web applications infrastructure, this code should compile. And see, we will now have an extension method which has strongly typed IntelliSense, which is quite cool. And if for some reason the index action is changed, this will start throwing a compile time error, and I will not be able to run my app with broken links. This extension method works for same controller too, if you want. But you can write another one which does not need to provide the controller, as you wish. I prefer to have an explicit controller specification here because it's easily readable, but as you wish, it's up to you. Okay, let's implement that method and make it work. First, I will need to check whether this provided expression is actually a method call. If the provided expression is not a method call, I need to throw an error, because expression of action could be anything. Could be, for example, this, and it will still compile. Yeah, okay, that will not compile, but you can, for example, say that add model error, and that's not a valid method call because we have a property accessor here, and that's not a valid method call expression. So because users can write whatever they like here, we need to make some type checks. So currently what I want to do is I need to check whether the body of the lambda expression, this is the body, is a valid method call. This can be done with redirect expression.body.nodeType does not equal to expression type call. This will give me a good defense against invalid expressions, and I can write provided expression is not a valid method call, and I can provide the redirect expression body so that the developer can see what the problem here is. Cool. Okay, we save that. Now what we need to do is we need to extract the action name. Extracting the action name from the expression is quite easy. Redirect expression. First I need to cast it, sorry. Var method call expression. I need to cast the body of the lambda expression to method call expression. Redirect expression body. And then I will have access to the method name. This will extract the action name from the from this call. It will extract index as a string. The only case this redirect won't work is if I have an action name attribute here, providing another value. I will show you how to solve that issue in a moment. Okay, we need the controller name. The controller name can be extracted from the controller dot name, and since it has the full name, we need to remove the suffix. So we need to remove the controller suffix. That's actually quite easy. Replace name of controller with string empty. Of course, you can write controller as a string, but after all, we're trying to follow best practices here. I'm currently examining the expression trees to show you the example here, but you can also do that. You can also get the controller name from controller.controller context action descriptor controller name. You can get the controller name from here. You can get the action which calls the current action from here, if for whatever reason you need it. So the other way to get the controller name is by using the controller type. But of course, that's only the case when you redirect to the same controller. If you redirect to another controller, this one will not have the available information, and you will need to write down reflection here. Okay, so we extracted action name, we extracted controller name. And now what we can do is we can return, what's wrong with this code, return this, not this, controller redirect to action and call the actual official action name. If you're worried about performance overhead, this is not a lot of code to provide a huge overhead. As I said, we've been using this kind of approach in a lot of our applications and everything works fine. My approach to coding is always provide better development experience. For example, removing magic strings, writing cleaner code, and if you hit performance from your approaches and from infrastructure, then change it back. For example, for the question, should I use entity framework or should I use SQL language directly? You should use entity framework. It's easier, it has compile time checks, it saves you from deep database injections and so on. So you have a lot of added value for the overhead it provides on the performance. So you should use entity framework, and if you hit a performance problem, then change it. But don't change it and don't write it in a difficult manner to make premature optimizations. It's not worth it. Always prefer to make your development experience better, because nowadays hardware is quite fast, and if you hit a problem somewhere, optimize it then. I will always prefer to write this code, like having a little bit of expression tree parsing instead of writing magic strings, because it took us 2 days to fix all the links in our applications when we hit the problem I told you earlier. So prefer to write cleaner code, better code, easier code, and when you have a performance issue, then optimize. That's the better approach, because if you don't measure, you won't know whether you have a performance issue. So it's not a good idea to say, oh man, you're using too much reflection here, you're having 3 lines of code which are calling some reflection crazy stuff, and you're calling some expression trees which are also advanced. So I don't know about your approach, it's a bit of strange and I may hit performance issue and so on. That's not the case. If you don't measure, you will not know what is the performance consideration here. So use code which is always clean and allows you to be a safe developer, like here. And if you have issues, then fix it. Stack Overflow uses this approach. They use entity framework, and when they hit a problem, they change it to SQL language with their ORM dapper. So this approach works fine. Whenever you can, write it the fastest way possible. When you hit a problem, optimize them. Premature optimizations is never a good thing. Okay, this was a side lecture about optimization. So this code now should work correctly, and let's try it. I will go to another action /about control /about. So I need another /about, and as we can see, we were redirected to the home page immediately. If we analyze the network tab and again hit that, I will see that the about method returns a redirect to the home action, which is exactly what I wanted. So we implemented that, and was it hard? I believe no. I believe it is quite easy to implement that method. Well, let's make it a bit more harder, and to make it harder, I will introduce RouteVers here. So essentially, as you saw, I changed the method and now I have a compile time error, which is exactly what I was searching for. If I had the normal redirect, this redirect to action with index or name of index, doesn't matter, this action would still compile, but the action will generate wrong redirect. Additionally, if I provide the root values, if I change the name of the value, for example, the query now becomes text, I won't receive any compile time check here, but the redirect will no longer generate the correct query. So let's fix that by using the expression trees, and here it gets a little bit more advanced, but still it's quite easy, so bear with me. Okay, to make this code work, now C# wants from me to provide int-id string query, and see the IntelliSense. It gives me a cool suggestion. What are the root values? I don't have such experience with the normal approach, so I can write my values here. Now all we need to do is to parse them. So to parse them, I will create a new method which returns root value dictionary. Root value dictionary is essentially a dictionary which returns string and object representing root values. The name of the key here is the name of the root value name, and the value here is the root value. So Behind the scenes, ASP.NET Core generates a dictionary which has ID key with value 5 and query key with myTestedASP.NET value. So if we create such dictionary and give it to this method, we will solve our issue here. So get or extract root values. I want to extract root values from the method call expression. We will need first I will need to get the parameter names. I will need to get the name ID and the name query. These are available in the method info by reflection. So to get the parameters, I will have to use expression dot method, which is a normal reflection. We are no longer using method info. We are no longer using expression trees here. That's normal reflection, which allows me to call get parameters. I will use a link here. If you are concerned whether a link is having performance issues, you can use 4 cycles, but like I said earlier, use it the simple way possible, then the simplest way possible, then optimize it if necessary. So I'm going to use link. If in the future I decide that this method is slow, I may cache it, I may remove the link to use normal arrays and for loops and so on. So okay, for each parameter I would like to get the name. This will give me an array containing both parameter names. Essentially what I want the names of this method here, these parameters here, to use them as a root values in my extension. Okay, great. The parameters are cool, and now I have to extract the values. The values here are constant expressions. In my previous video I explained how we can extract constant expressions, and I will show you when these expressions will not work. Let me extract the values. The values are available in the expression tree arguments. The expression tree arguments are essentially the arguments of this method call. So if I evaluate all arguments and cast them as a constant expression, that may work. Let's see. Arguments. For each argument, I will try to cast it. Constant expression argument. But remember, we need expression argument node type. We need to check if the expression is correct, because as we already know, the user can write whatever expression he likes. And I will return no if the expression is not a constant, and if it's a constant, I will just return the constant expression value. This will extract 5 and myTestedASP.NET right away and will provide it as a string here. I will need that as array, and I will need that as array too. Let's do array. Good. Now all I have to do is create the root value dictionary. and add all values in it. So I need to call add names from I and values from I, and return the root value dictionary. Essentially what I did here is I extracted root values. I need to extract the root values, I need the root value names, which is ID and query in this case, and I need the root value constant values to use them. So I extracted the names from the original method. I get the parameters with reflection, I get their names, and with values I extracted them by using the expression tree and casting the expression node as a constant. And let's see whether this will work. Var root values equals extract root values from the method called expression, and then I will provide the root values here. Let's run that. Let's see whether the root values are correct. My dictionary should contain ID equals 5 and query equals my test.asp.net. I will hit that and see that the root values are 2, the keys are ID and query, and the values are correct. So I'm using the default implementation, which allows me to pass either an object of anonymous properties or a dictionary of string and object, and it will convert the root values correct. Let's see how it converts them. If I hit another, I will see that it redirects me to /home/index/5, and it will append the query correctly, which is quite nice. Actually, our code works. Let's see the cases where it won't work. The first case is something we use a lot in our controllers. Most of the times these parameters here are not provided as constant. Most of the times they come from a database, they come from a variable. So essentially the ID here will be provided like this, and the ID here is no longer a constant expression. It's no longer a constant expression, and our code will not work. If I try to redirect, I will see that the ID is missing, and it shouldn't be. So if the ID is missing, let's see what's wrong with parsing the value. And I know what's wrong, it's not a constant expression, so it returns null. My code currently, so the first argument, this is exactly the value of the argument. It's not a constant expression, it's some class, auto-generated class, and some field name ID. I explained in my previous video how expression trees create hidden classes to save their state, so this is the case here, and that's why it's not working with the constant expression. How to solve that? We have two approaches. The first approach is simple, and I'm going to implement the simple one here. And the second approach is kind of more advanced. I'm using it in my framework. The second approach extracts the value from the hidden class. The hidden class I just showed you, the auto-generated class. It uses reflection and it's a bit advanced to understand, so I'm not going to use it, but I am going to show it where you can find it in my project. So you go to source, abstractions, utilities, expression parser, and down below there it is. This is the code that parses constants, We already did that. And this is the code that parses variables. This is the check I did. I check whether it's a member access to a field, because the ID will be a hidden field in the class, and then I extract the value from the field. It's a little bit more advanced, so I'm not going to show you how to do that. I'm going to show you a simpler way of providing the ID value by using compile. I know I said in the last video that compile is the slowest operation we can do on an expression tree, but trust me, again, I have used that code in many of my web applications and it's working fine. Okay, what we can do here is we can try to create another expression, a lambda expression, which will be essentially like this one. I will create a very simple function which I'm going to invoke, and the function will be with this syntax. Function which does not receive any input and returns the argument. So how to do that? I can use expression trees. I can create a lambda expression. If I want to create a lambda expression like this one, I will need a func which returns the type of the argument. Since I don't know the argument, I will use a func of object. So if I create a lambda expression from this argument, essentially this creates this func. I will create that func, then I will compile it and will invoke it. And when I create this func, I will have runtime created delegate of this type, and when I invoke it, I will receive this argument. This is essentially like creating a function, private static object, some func, return some value. Essentially, I'm creating this method with a lambda expression. That's cool, but that won't work because argument is string and it will not be able to be passed as an object here. The C# language will throw an exception. Let's see. It didn't throw, but it didn't work. Let's see what's wrong. If I hit another again, the first node type is the ID, which is not a constant. Okay, yeah. So I received the exception I told you. Expression of type system int cannot be used for return time system object because the ID is of type int and I'm trying to create a func of object. How to solve that? To solve that, I will cast it as an object in the function here, and that will work. But in order to create that cast, I will need to use another expression. So I will create convert expression, which is, let's use the full name expression here too, because I started it this way. Here too. So convert expression will be expression.convert, and I will provide what I will want to convert. I want to convert the argument to type of object, and that will create this function. It will create function which will cast the argument as object and will return it as value when I run that. This is the simpler way to convert that value. The advanced way was in my code. What's wrong with you? Yeah. I'm again using the argument here, and I have to use the convert expression because currently I create a convert expression but don't use it, and the end result is like this. So I need to pass the convert expression here to create a lambda expression from the convert. That should work. Here it is. It extracted the value correctly, extracted the query, generated the link correctly, and this code is now working great. You can use it to generate links, to generate redirects, create a detection, accept a detection, and so on. The only case this won't work is if the action has an action name. And if the action name is something else, this redirect should not work. Here it is. No route matches the supplied values. And that's normal because now if we want to redirect to this action, we need to say something else here, which is essentially not the case with our extension method because we are saying to redirect to the action name directly. Let's fix that. Let's create private static string get action name, and I will receive the method call expression again. I may receive the method info directly, so let's do it. Oh, it's fine both ways. Okay, I will get the action name. First method name is the method.name. That's easy. Var action name attribute expression.method.attributes get custom attributes or get custom attributes. I will say I want to search for action name attribute like this one, and I want to say inherit. So I received an object of type, let me do it like this, give me all the attributes of this type, call for store default, and give me the name, and then return action name or method name. And this should work with action names too. Let's try it and see whether we're finding the correct attribute currently, and you know why the home action is called something else, so the index is failing. That's why it gives me an error initially. So if I write down here and see, the action name will be something else, and if I the error now is not because of the redirect, and it's because something else is not it's not a valid view name, so I will just provide this one to make sure everything works correctly. And cool. Now I have a redirect action that is working quite great. And because we are using the official redirect to action methods, our code will work with both route attributes and with conventional routing. So our code is working fine now for all available cases in the ASP.NET Core framework. What we can improve here, we may decide to cache something. We do some analyzing of expression trees, some reflection, we may cache something, as you wish. For example, you may cache the controller name. If you measure, it will be faster. The way to cache something is private static read-only concurrent dictionary string, for example, action name cache. For example, this will cache the action names. Again, I'm showing this as an example. You should measure whether it's working. It may not worth it to add additional memory consumption and additional caching in your application. You should measure and decide whether to implement it. I would like to say that initially, if you search in the history of this project, we implemented caching. We added caching in all expression parsing. We cached everything. We cached the controller names, the action names, everything, and afterwards we measured in our application and decided the cache is not worth it, so we removed it. So as you wish, you may do it or may skip it. I prefer to skip it, and if something starts slowing down, if my app is running slower, I may analyze why it's running slower. But I will give you the way how it's the best way to cache it. Use concurrent dictionary because ASP.NET Core runs a request in parallel. So if you don't use concurrent dictionary, you will have a race condition on your cache. So that's the way to do it. And return action name cache get or add. I will need a string key. The key will be a combined value from the controller name and action name. That should be unique enough. If it's not unique enough, then you will need to provide a better key, but for this sample it should work. So first I will say method name, then I will say expression object type name. The expression object type name is essentially the object on which the method is called. So the object on which the method is called is this C, which is home controller. And what I'm giving here is saying I want the cache key is to be index slash index underscore home. That's my idea. Of course, if you have root values, you should include them in the cache too, but as you decide. I'm showing a simple example here. Again, don't cache unless necessary. In our library, we decided the cache is not needed, so we removed it. But if you think it's better to have a cache for some of these reflection calls, do it. And I will cache this value like this. and my redirect to action should continue to work correctly. Done. You can implement similar extension methods to all link generation functionality in ASP.NET Core, for example actions, for example redirects, created at action, exception detection, and so on. Okay guys, that's it. Thank you for being with me. I hope you liked this technique. It will save you. It will provide you a good development experience writing your web application using expression trees, because in my last video you may tell that expression trees are not valuable for you, but actually you may implement such magical methods to save you from writing down magic strings, for example. Okay guys, if you like this video, hit the thumbs up. You may subscribe for future lessons. I try to upload videos every week. Additionally, you may check my projects, take a look around, give it a star, watch them. You may fork them, play with them, whatever you like. And last but not least, these videos and these projects are supported on Patreon. So if you really want to help me, you may consider becoming a backer or make a one-time donation on PayPal or buy me a coffee. On Patreon and on Open Collective, some people already donated and I'm extremely grateful for that. And I write all of my backers are listed here, essentially forever, because when somebody decides to stop supporting for whatever reason he may have, I list him here in the previous supporters. Thank you, appreciate it, and goodbye.